You're looking at a machine that costs more than a luxury yacht, a private island, and a fleet of supercars combined. The F-35 fighter jet, priced at over $100 million per unit. But what makes this aircraft worth more than most people will earn in 10 lifetimes? Today, we're going inside Lockheed Martin's secretive Fort Worth facility to discover exactly what your tax dollars are building. Step inside the F-35, and you immediately understand why this jet is insanely expensive. First of all, this aircraft screams through the air at 2,000 kilometers per hour. But speed is only part of the story. The real magic happens when enemy radar tries to find it. According to Lockheed Martin engineers, the F-35's radar cross-section is roughly the size of a golf ball. Think about that for a second. A jet weighing over 13,000 kilograms appears on enemy radar as something you could hold in your hand. This stealth capability comes from every single design choice. The angles, the coating, even the paint serves a purpose. Nothing about this aircraft is accidental. The F-35 actually comes in 3 distinct types, each engineered for specific combat scenarios. The F-35A is your traditional runway jet, the workhorse that most air forces around the world operate. The F-35B is where things get wild. This variant can take off from incredibly short runways and land vertically like a helicopter. Watch it hover in midair, and you're seeing engineering that would have seemed impossible just decades ago. Then there's the F-35C, built specifically for aircraft carriers with reinforced landing gear and larger wings to handle the brutal stress of carrier operations. But the crown jewel of the F-35 sits right on the pilot's head. The Gen 3 helmet costs a staggering $250,000. Yes, you read that correctly. $250,000 for a helmet. This helmet is a supercomputer that projects critical flight data, enemy positions, and targeting information directly onto the visor. That way, pilots don't look at traditional instrument panels anymore. Everything they need appears right in front of their eyes. The Lockheed Martin facility in Fort Worth stretches over a mile long. Walk the production floor, and you're witnessing organized chaos at its finest. Over 100 F-35s are in various stages of assembly at any given moment, with more than 18,000 skilled workers contributing their expertise. This factory has been producing aircraft since World War II, according to company records. Every day, workers arrive knowing their job contributes to national security. So the precision required is extreme. On a stealth fighter, a tiny imperfection can mean the difference between invisibility and detection. For instance, that minuscule gap in a panel seam could reflect radar waves and compromise the entire mission. Engineers use advanced scanning technology to verify that every component fits exactly as designed, down to tolerances measured in fractions of millimeters. The manufacturing process relies heavily on computer-aided design and robotics. Human expertise remains irreplaceable. Skilled technicians inspect welds, verify electrical connections, and ensure hydraulic systems meet exacting standards. Each F-35 contains over 300,000 individual parts, sourced from suppliers across the United States and allied nations. The supply chain complexity alone would blow most people's minds. Inside the metrology lab, you enter a world where imperfections simply cannot exist. This room maintains strict environmental controls because even temperature fluctuations could affect measurements. Here, technicians use laser scanning technology to create 3-dimensional models of aircraft components, comparing them against digital specifications. Panel is off by even a tiny width, it gets rejected. The tools in this lab look like they belong in a science fiction movie. Every single panel, every structural element, every piece that will eventually become part of an F-35 passes through rigorous inspection protocols. We are talking about ultrasonic sensors that can detect microscopic cracks inside composite materials that are completely invisible to the naked eye, and X-ray imaging that reveals the internal structure of components to ensure there are no hidden flaws. Why such extreme measures? Because at supersonic speeds and high altitudes, the smallest defect can have catastrophic consequences. A crack that seems insignificant on the ground can escalate rapidly under stress, potentially causing structural failure. So the metrology lab has one job: catch these issues before they ever leave the factory floor. Research published in the Journal of Aircraft indicates that advanced composite materials used in modern fighters require inspection methods far more sophisticated than those used on previous generation aircraft. Siren isn't just any test pilot. She's the only female F-35 test pilot at Lockheed Martin, navigating a career path that remains heavily male-dominated. Her call sign sign Siren, earned through the traditional military aviation custom, represents her identity in the cockpit. Every pilot gets a call sign, usually given by fellow aviators based on personality traits or memorable incidents during training. Being a test pilot requires skills beyond exceptional flying ability. They push jets to their absolute limits, documenting how systems respond under extreme conditions. So when Siren climbs into an F-35, she's not just flying, she's gathering data, testing new software updates, and verifying that modifications perform as engineers predicted. The challenges of being a female pilot in this field go beyond the obvious. Equipment designed for average male body dimensions doesn't always fit properly. The G-suit, which prevents blood from pooling in the lower body during high-G maneuvers, was originally engineered around male physiology. Helmets, ejection seats, even cockpit layouts assumed male proportions. Modern aviation has made strides in addressing these issues, but gaps remain. Despite these obstacles, Siren's expertise commands respect. In the cockpit, gender becomes irrelevant. What matters is skill, decision-making under pressure, and the ability to handle a multi-million-dollar aircraft pushing the boundaries of physics. Her typical day involves pre-flight briefings, simulator sessions, actual flight tests, and extensive debriefing where she provides detailed feedback to engineering teams. The F-35 simulator provides an incredibly realistic training environment without the astronomical costs of actual flight hours. Operating a real F-35 costs approximately $36,000 per flight hour, according to Department of Defense figures. So naturally, the simulator delivers comparable training value for a fraction of that cost. Inside the simulator, the realism is top-notch. The controls respond exactly like the actual aircraft. The stick and throttle feel identical to the real thing. Pilots control speed, direction, and altitude using these primary flight controls while managing dozens of aircraft systems simultaneously. That red button everyone asks about? Yes, it launches missiles or drops bombs, but only after multiple safety protocols are satisfied. The sensor fusion technology represents perhaps the F-35's greatest advantage. Traditional fighters require pilots to mentally combine information from radar, infrared sensors, electronic warfare systems, and visual observation. The F-35's computers do this automatically, presenting a unified tactical picture. Pilots see friendly forces in blue, threats in red, and unknowns in yellow. The system tracks hundreds of objects simultaneously, prioritizing threats and recommending responses. Experiencing high-G maneuvers in the simulator provides a taste of the physical demands. When a fighter pulls 9 Gs, pilots experience 9 times their normal body weight. Blood rushes toward the feet and vision narrows. Without proper technique and the G-suit's assistance, pilots can lose consciousness in seconds. The simulator safely introduces these sensations, teaching pilots to perform the anti-G straining maneuver, a breathing and muscle tension technique that maintains blood flow to the brain. The Gen 3 helmet looks futuristic because it is. Creating one requires 3D, scanning the pilot's head to ensure perfect fit. Even slight pressure points become excruciating during long missions, so the custom fitting process is critical. The helmet contains embedded sensors that track head position, allowing the aircraft's cameras to display imagery from whatever direction the pilot looks. Want to see what's directly below the aircraft? Just look down. The helmet displays video from cameras mounted on the underside of the fuselage. This see-through capability transforms combat awareness. Pilots are no longer limited by the physical cockpit structure blocking their view. They can effectively look through the floor, through the wings, through any part of the aircraft. In a dogfight, this advantage can mean the difference between acquiring a target first or becoming a target yourself. The G-suit serves a simpler but equally vital function. During high-G maneuvers, air bladders inflate around the legs and abdomen, applying pressure that forces blood back toward the upper body and brain. Without this assistance, pilots would black out during routine combat maneuvers. The suit inflates and deflates automatically based on G-forces, requiring no conscious pilot input. Research in aerospace medicine has shown that modern G-suits can improve G-tolerance by 2 to 3 Gs compared to flying without one. The complete pilot ensemble includes a survival vest packed with emergency equipment, a flight suit designed for maximum mobility, and boots that can withstand ejection forces. Every piece of gear serves multiple purposes and undergoes rigorous testing. When a pilot ejects from a disabled aircraft, they're experiencing forces that can cause serious injury. The equipment must protect them during ejection while providing survival tools once they're on the ground in potentially hostile territory. Standing next to an F-35 on the ground is an experience that changes you. Every surface, every edge, every angle serves the stealth mission with ruthless efficiency. Walk around the aircraft slowly, and you'll notice that the aircraft has absolutely no right angles anywhere. Engineers deliberately avoided right angles because they reflect radar waves directly back to their source like a mirror bouncing light back at you. So instead, radar energy scatters in directions away from the transmitter, making the aircraft nearly impossible to detect. Look closely at the skin of the aircraft. That coating contains materials that actually absorb certain radar frequencies. The exact composition remains classified, but what we know is that the coating is so sensitive that mechanics must be incredibly careful when working on the aircraft. The edges of the wings, the tail surfaces, everything is angled in very specific ways. If you measured the angles carefully, you'd discover they're all parallel or perpendicular to each other. Engineers call this planform alignment. All these carefully aligned edges work together to bounce radar signals away from enemy receivers. Now, move to the front of the aircraft and you're staring at the nose cone. This seemingly simple component houses the AN/APG-81 active electronically scanned array radar, one of the most advanced radar systems ever installed in a fighter aircraft. What does that mean in plain English? This radar can track multiple targets simultaneously, potentially over 100 different aircraft or missiles all at once, while also jamming enemy radars and intercepting communications. It does the work of 3 separate systems from older generation fighters. The radar is so powerful that there are actually safety zones around the aircraft when it's operating. Ground crew must stay clear because the energy output could literally cook you. The internal weapon bays represent a key stealth feature that sets the F-35 apart from almost every other fighter jet in the world. Carrying weapons externally, like older fighters do with missiles and bombs hanging under the wings, creates massive radar reflections. Those external weapons light up on radar screens. The F-35 carries up to 18,000 pounds of ordnance internally. That's the weight of 4 full-size pickup trucks worth of bombs and missiles, all hidden inside the aircraft where radar can't see them. Now let's talk about something that sounds impossible, but is absolutely real. The F-35's radar cross-section compared to other aircraft. To understand the F-35's radar cross-section, compare it to other objects you see every day. A conventional fighter jet like an F-15 Eagle, which is still an amazing aircraft and has never lost a single air-to-air combat engagement, has a radar cross-section of roughly 10 to 15 square meters. That's about the size of a ping-pong table or a small bedroom. On radar, an F-15 looks big and obvious. A large bomber like the B-52, which has been flying since the 1950s, has a radar cross-section of around 100 square meters. That's roughly the size of a tennis court. These aircraft show up on radar screens from hundreds of miles away. There's no sneaking around in a B-52. The F-35's cross-section measures around 0.005 square meters. That's smaller than a golf ball, smaller than your fist, smaller than a smartphone. This comparison illustrates the dramatic difference stealth technology makes in actual combat situations. Even more impressive, the F-35 can detect enemy aircraft long before they can detect it. The F-35's advanced sensors can spot and track enemy fighters from over 100 miles away. Look at the engine exhaust at the rear of the aircraft. Unlike older fighters with circular engine nozzles, the F-35 has a flat rectangular exhaust. This shape helps reduce the infrared signature, making it harder for heat-seeking missiles to lock onto the aircraft. The exhaust also mixes hot engine gases with cooler air more quickly, further reducing the heat signature. Modern missiles are incredibly sophisticated, but they can't lock onto a target they can't see clearly. So here's the real question that matters. With each F-35 costing over $100 million and requiring thousands of hours of specialized maintenance, is this incredible machine worth the investment? Or has military aviation reached a point where drones and unmanned systems make more sense? Let us know what you think in the comments.